Last lesson we looked at adding and subtracting like terms to simplify expressions. So for example, we had this expression here, 3x plus 2x. We were collecting like terms to say that the answer is 5x. We're going to use a different strategy when multiplication is involved. So let's have a look. So the first part of the lesson will be based on an understanding of terms. And so how many terms have we got here? Well, pause the video and have a think about it. Okay, so hopefully you've had a bit of a think about it. And on what I'm willing to bet is that most people will say that this has two terms. That's one term, that's another term. But in fact, this is one term only. Now remember the definition of a term. A term is something that algebraically we add or subtract. So 4x plus 5a. That's the first term, that's the second term. Or 4x plus 3, 4x take 5, etc., etc. All of these are two-term expressions. This, in fact, is just one term. Okay, and what I'll do is go on to explain why it's one term. So, like terms are only relevant when more than one term is being added or subtracted. With multiplication, I'm not interested in whether they're like terms or not, and I'll show you why. So here's our first example here. We're multiplying n times k. And algebraically, all we do is we write that as nk, or kn if we want to put it in alphabetical order. So that's all I need to worry about. So notice that these wouldn't be considered like terms, but it doesn't really matter. We're just rewriting this without a multiply sign. Let's have another look at it. Look at another example. So we're simplifying 2x multiplied by 3. Now again, we would say, oh, but these aren't like terms. But actually, I'm not even interested in whether they're like terms or not. All I'm going to do is rewrite this with expanded form. So I just put some multiply signs in wherever they belong. Now, because multiplying allows us to do this in whatever order we like, I'm just going to do it like this, which is 2 times 3 times x. Now we know what 2 times 3 is. That's 6 multiplied by x is going to be just 6x. Okay, so this is 3 lots of 2x, which is 6x. All right, we've got 9p times 2. So let's do that trick again of going 9 times p times 2. Okay, so what we're going to do is write this as 9 times 2 times p times p. 9 2s are 18. Now p times p, that's just p squared. And it would be multiplied by p squared. We don't write that multiply sign, so it's just 18p squared. Right, and finally we can look at this one here, which is 14 times 0.5 times a times b. So all I've done there in one line is put my multiply signs in and reorder it the way I wanted. Right, now this is half of 14, which is 7 times a times b, or 7ab, 7ba, whichever one you like of that. Right, and my last example. So, right, a common mistake is often made on these ones. So I'll show you the mistake version first, and then I'll show you the working out that I want you to do. Right, so many students will start this up going 4m times 3, take m times 2, so they'll do this first. So they'll go 12m, take m times 2. Then they just process the operations in order that they see them. So they'll do 12m, take m, which is 11m times 2. Now that will be 22m. All right, so the mistake is here. All right, so in doing the subtraction first, what I've done is change the order of ops. The order of ops say that the multiplication should get done first. So therefore, this line here is not the same as this line. Okay, so this is the wrong move here, right? Which means that our overall answer is going to be incorrect. Now, what's the right way to do the problem? Well, I'll rewrite it. And what my suggestion to you is that you know that that has to get done first. And because of order ops, that has to get done second. So the best thing you can do is actually bracket up to force the order of ops. Even though it would happen that way, with brackets, I don't know, it just seems to be more visual. So we're going to do 4m times 3, which is 12m. Take away m times 2, which is 2m. And our answer is 10m, certainly not 22m, which was over there. All right, so check the Firefly page for the set work. And as always, ask me if you've got questions.